So today we are covering how to balance these reactions. So we have P4 plus S8 makes P4S3. Okay, step one, write the thing. Step two, how many of each atom are there? There's 4, 8. There's 4, and there's 3. Gross, right? Yes, it is quite gross. So I know that I can only have multiples of this, right? So if I multiply it by 1, I have 4 potassium and 3 sulfur. If I multiply it by 2, I would get what? 8 and 6, right? If I multiply it by 3, I would get 12 and 9. If I multiply it by 4, I would get
16
and 12. If I multiply it by 5, I would get
20 and 15.
If I multiply it by 6, I would get
Wait, 18.
No, 15.
24.
Silly. Yes.
Is this going up by 4? Okay. Are we bothered? Let's keep going.
We should want to
Yes.
not add 4.
Wait, why are we going more?
Okay. These are all the possible combinations that we could have, up to 8. Yes?
Yes.
So, which of these is going to be a multiple of 8?
24. 24.
So the only possible way I could even remotely make this work is if I have 8 of these. Now let's hope that 4 goes into 32. Oh wait, it does.
Mr. Villa, how did you get P4S3?
That was given in the
Can
problem.
we pause real quick to
Yep.
process all of this?
Yeah.
Isn't 8 times 2 also 18 though? Okay.
8 times 2 is 60.
16.
It's okay. I don't know your math teacher, so.
So, Mr. You changed.
That guy died like 4 periods ago grading pre-calc tests.
So you changed.
Oh, so ours.
But they improved because you saw
How does that work actually?
Actually, no, they were average.
Okay, so the idea is that you have to put numbers in front of all of these to make them equal, right?
Oh, all of them.
Okay? Yeah, well, not all of them all the time, but in this case I did, right? So P4 and P4, see how they're the same?
Yeah.
So like, no matter what, on this side of the equation, this number has to match that number because the potassium has to equal out.
Isn't that
Right?
phosphorus?
Phosphorus, thank you. I'm having a day today. So, these two numbers have to be the same, no matter what. So they're going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever that number is, it has to be the same here and here. So I'm not even worried about potassium. Phosphorus. Phosphorus. I don't care. Right? I can always make that number match this number. What I can't get to match is this sulfur, which has 8, and this one, which has 3. The only way I can make those two work out, which are the real problem, is if I multiply this one by 3, and if I multiply this one by 8, that gets me 8 times 3 sulfurs, which is 24, and 3 times 8 sulfurs, which is 24. Then I simply work on balancing the rest. Well, what's the rest? I need 32 phosphorus here, so I have to multiply that by 8. So you're playing a game with balancing these.
How is 3 going to 24? Oh, 6. Or 8.
3 times 8 is 24. Yep. Okay, let's try the next one.
These are fun.
These are,
Okay.
I like little puzzles.
they are little puzzles. I like that. They're quite puzzling. There's potassium. We found it.
Potassium.
Okay, how many potassium do I have on the left side?
1.
How many chlorine do I have on the left side?
1.
How many oxygen do I have on the left side? 3. That's a 3. Sorry. How many potassium do I have over here? Do them in the same order so you don't confuse yourself, right? 1. How many chlorine?
1,
How many oxygen?
2,
2. Okay, where do we start? Potassiums are the same. If we look carefully, we see that this number has to match this number. Right? Because in order for the potassiums to equal, these two have to be the same. So, I really don't care about these two. What I do care about is this oxygen right here. How do I make 3 equal 2? What do both of those numbers go into? 6. So if I multiply this one times 2, and this one times 3, my oxygens equal out. Now, all I have to do is fix the last one. Now I have 2 there, I have 1 here, but I know these two numbers have to be the same. So I'm done. Yeah.
What's the S, like the parentheses?
They're saying it's like solid or liquid or gas. That's all that means. This one was probably one of the harder ones. So you have to go up to 8. And you didn't expect to go up to 8. So you're like, eh. Okay. Next, we have the following. What's Ag?
Gold.
Silver. Okay, which two numbers must be the same? Risa.
The same, the oxygen.
So it's either this one, this one, this one, this one. So which pair must be the same? Which have to have the same coefficient in front of them? And which one? So I have 1 silver here. So that would be the same as the number of silvers here. Okay, think that through for a second. I know. That's okay. Now you do. So anytime I twist this knob, right? Anytime I add more of this guy, I have to add more of this guy. These two numbers have to be the same. Why? Because this is the only place where we see silver here. This is the only place we see silver here. So they have to match. Yeah.
Wouldn't that mean that copper and the other copper have to be the same exact?
These two numbers also have to be the same. Why? Because if I increase the number of copper here, then the number of copper at the end has to increase. So really now I only have to solve for 2 numbers. Cool. Let's write out how many of each atom we have. You'll see it when I write out the table. How many silver do I have here?
1.
How many nitrogen?
1.
That was just one of you. Let's try that again. How many nitrogen?
1.
Oxygen?
3.
Copper?
1.
Over here, how many copper?
1.
Nitrogen?
2.
2. There's 2 of them. It's in parentheses. Oxygen?
6.
Silver?
1.
1. Man, silver looks good. Copper looks good. But everything else is messed up. Okay. So just looking at these numbers, I have 3 oxygen. I would like to have 6. Which one should I multiply by 2 on my reactant side, Grace?
I'm not
Give it a try. Give it a try.
I literally don't know. I literally don't know.
So it's got nitrogen, right? So it's nitrate or nitrite. Which one is it?
Silver nitrate.
Silver nitrate. Okay. So
Can
can someone check that just to make sure?
Yeah,
You don't want them to be right.
Alright, so,
Yeah.
Wait, wouldn't it be nitrogen oxide?
CO3 is nitrate.
Not nitrate?
it's a polyatomic ion. Okay, so I'm gonna multiply this guy by 2 because I know that I want twice as many oxygens. Fortunately, that messes up everything else. That's okay. Remember that I said that this one has to be the same as this one because the silvers have to balance, right? So that means now we're here. Are we done?
I have a question.
Are we done? I see your question. I'll get to you. Are we done?
Yeah.
That number matches that number. 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 We're done. So these are just ones. You don't have a question.
So my question is, if we were trying to like make oxygen like neutral, why are we doing things to like silver? Like why do we add stuff to silver?
Yes, because they're all one compound. Imagine like you have like a little bucket of this silver nitrate. It's actually really cool stuff. It'll turn your skin brown, like if you pour it on yourself. Fun time. So we'll experiment with it later. Like you can tell who did that lab because they have like just like brown stuff all over, like little brown spots and brown specks. Because it's just like it gets all over you. So, is it a question about silver nitrate or is it?
It's a question about the second question.
Oh, because I'm trying to answer it. Let me answer her question. Wait, excuse me. Answering your question. Hello. Okay. We have like in your car how you have little knobs and you can turn them, or maybe you're not allowed to turn the knobs, right? But like you have little adjustments you can make, right? You can put as much of this as you want. There's like a little bucket of silver nitrate. It's actually a liquid, but anyways. So you like pour it in. So I'm pouring 2 of these for every one of these. But I can't just change the number of oxygen I have because that changes the compound. So I can't be like, oh, just have more oxygen there. That doesn't work. This is one thing. So like, you have to do multiples of that whole thing. So yeah, it does mess up everything else, and then you just keep adjusting. Okay, question.
How do you say the second one with the copper? Copper.
This is copper.
No, the second one on the other side. Like,
Copper nitrate.
That'd be like
Probably copper 2 nitrate.
or like ion. Is that
No.
current?
Copper 2 nitrate. Because if you know the charge on nitrate and you know the charge on copper, then you can figure out the correct number. Okay, let us. Still some leftovers from years past. Try the next one. Okay, next one is. What is that called?
Hypoxidate.
Okay, so
It's an acid. Wait,
it's
no,
an
it's
acid.
wait, isn't it?
Hyperphosphate.
Hyperphosphate.
If only the H and the O are connected, right? That means it's a basic.
So this is phosphate.
Phosphoric acid. Oh, really, mister? Ah!
Phosphoric acid.
No.
What'd you say?
She's smart.
Would you say hypophosphoric acid?
No, because
It's
it's
like if
phosphate.
it ends with no, if it's like the start of an H, it's probably acid.
Okay, so phosphoric acid. Yes. Okay, so let's count. This one's horrible. How many hydrogens? 5.
Oh, 5.
5.
How many phosphorus? Oxygen?
2.
6.
6.
Oh.
Barium? 1. And we already did hydrogen. Whoops.
Are you confused by those?
No, sorry, got 2 more. Like, why is the hydrogen 3? Oh, I thought
Yeah.
that was an equal.
Over here. Why did I put that in such small space? It's like you guys on your math test and you're like, oh, I'm gonna get it. I'll make my whole problem fit here. Answer. Just get another piece of paper. Okay.
That's wasteful.
Okay. Hydrogen. This side.
2.
2. Phosphorus,
One.
2. It's in the 2. Oxygen, 9.
Oh, yeah.
Barium,
Why 9 oxygen?
8 plus 1 is 9.
I missed.
Oh, oxygen.
I
Yeah.
didn't see H2O.
Oh.
It's there. It's all around us. It's in your copy.
Actually,
Like
it's more
75% of it.
The movie flushed away.
Is it the
It's
rat
actually
one?
more nitrogen.
Yeah, one, right?
Yeah.
Is
That movie keeps
that
coming
the
up.
claymation?
Yes. That movie keeps coming up in my life.
Okay, so
Yes. Oh my
What the
god.
heck? Satoshi?
whenever you're done,
I'm done, sorry.
where do we start? Oh.
In Smash, no.
So that's gross, right?
Yeah.
I don't know, barium. That gives me 3. Now how many oxygen? We have 6, 7, 8, 9, 10. And we have 3 plus 6 is 9. Okay. Gross? Sure. That's gotta be wrong.
Yeah.
No, that's right.
Yeah.
Yeah, I'll buy that. Add 4, add 4, add 2. Okay. Now, is it balanced?
No, because we have one right.
So where'd you add the 4 then?
Okay.
Yeah.
What 4?
Well, from like the oxygen, you had to add it somewhere.
Because there's 3 times 1 times 2.
Oh.
So that's 6 plus 4 is 10.
Oh.
And then 3 times 2 is 6 plus 3 is 9. Okay, so barium's good and everything else is trash. Okay, while we're breaking things, let's break. But let's get phosphorus to work. Notice that I'm leaving kind of the smaller molecules because we have this water here. I'm kind of leaving that till last. Like oxygen and hydrogen, leave it till last. Get everything else kind of balanced and then go from there. So phosphorus, I want 2, I have 1. So I can multiply this by 2. What does that get me? That gets me now, what, 12? 12 hydrogen, 2 phosphorus, 8 plus 6 is 14. Oxygen.
Oh.
That's gross.
Is this gonna be on the test?
Okay.
No,
That's
will be eventually.
You should put this on test. It's fine. Just
Okay,
instead of maybe just do this.
now this one's wrong.
It's a little bit more easier.
That one's wrong. That one's still right. This guy's right now. Okay, can I make the hydrogen right? Okay. I really don't want to touch this guy, right? Because that messes everything up. That messes up all the hard work we've done to get phosphorus and barium. So let's turn this knob. Okay, let's adjust the number of water. There's 2 hydrogens, so I don't want to think that hard. So let's get the oxygen fixed. I have 14, or I have 9. I want 14. How many do I need? Well, that's the wrong answer.
Jesus.
Well, that's actually how much you need.
You need 6 waters here. Because 8 plus 6 is 14.
Yeah, so why did you put 9? Because oxygen is 2 or whatever?
Because there were 9. Now there's 14.
Yeah, I forgot there's.
I know. Okay.
And now
Hydrogen 12 plus, that's it. Okay, do they all match?
Yes.
Horrible? Yeah. Undoable? No.
So why was it 14 and not 2?
Yeah, I'm still confused on the oxygen.
I'm still
Okay,
confused on that.
4 times 2 is 8,
Right.
plus 6 is 14.
But wouldn't you count?
Oh, okay, yeah,
Wouldn't
I
you
get it.
count the
You have
other-
to add 5 more. But you already have 1, so then it's 6, not 5.
'Cause
That's why your last step is to go back and check. Because you can be like, oh, I need 5 more. And then you put 5 and you're still 1 short. You doing okay?
Really?
Yeah, I'm really
Still stuck on
dehydrated.
berry.
And then the water.
They're stuck on the.
All right, last one. That's gross. This decomposes to make gross? Yeah. Go ahead and step out. Come back when you're ready. Both of you. Go back. Your face is turning red. I need you to calm down before
I'm yelling.
laughing. Okay. Enjoy life hitting you hard outside in the nice weather with the saguaros. What do you keep throwing? Stop throwing things.
Saguaro.
We don't throw things in class. Thank you. Okay. All right. On the left side. Sodium. How many?
One. Two. Sorry, I meant one. But two.
How many? Hydrogen. How many?
One.
Carbon.
One.
Oxygen.
3.
Right side. Sodium.
2.
If you're gonna be helpful, you can't be here. That's how it's gonna go. Hydrogen. Carbon.
6.
2. Oxygen. A lot. 3, 4, 5, 6. Okay. Which ones are easiest to figure out?
The one with the less.
So we know that this guy and this guy are super linked, right? Anything I do here, this one is going to be half of that. No, this one's going to be half of that. Right? Because there's 2 sodium here, there's 1 there. Okay? So whatever this number is can be half of that number. Because that's the only place where we see sodium. Everything else is a giant mess. There's hydrogens everywhere, there's carbons everywhere, there's oxygen everywhere. So our only constant here is that we see this sodium in both of them. So let's be lazy. Let's start there. How about 2 and 1? What are we left with? 2, 2, 2, 6. Hey, we're done.
Go.
That's it. It works out perfectly.
If I may say.
Oh yeah, because it multiples all of them. Okay.
Where's the, oh,
Good.
I know it's clicking
Test review.
a button somewhere.
All right, so that